Hello and welcome back. We'll continue looking at how to divide up data, and in the last video we looked at percentiles, and in particular percentiles break up data into 100ths. So we can talk about 1%, 2%, 3%, and when we're talking about percentiles we have the root cent in here, which means 100. So we can also talk about quartiles, and as you might expect, this is going to break up data into quarters, into fourths. So we can talk about 25% of the data, 50%, 75, and so on. So when we talk about the first quartile, what this is the value that separates the bottom 25% of the data values from the top. This is the same thing as the 25th percentile. The second quartile is going to be the value that separates the bottom 50%, or 2/4 of the data, from the top 2/4. And then the third percentile, the third quartile is the value that separates the bottom 75%, as in the bottom 3/4 of the data, from the top. Now, as I mentioned very briefly last time, the second quartile, the 50th percentile, is just the median. It's the value that divides the top half of the data from the bottom half of the data. So let's go through a quick example. Here I've got the first 13, say, prime numbers, the prime numbers between 0 and 40 listed. So out of these, let's find each of the quartiles. I'll start with the second quartile because this is the easiest. This is also the same thing as the median. For this one, we can count how many values we have. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So n, which is usually what we use to denote the number of data values, will be 13. So if we divide n by 2, we get 6.5. So we can round up to 7, and that the 7th number in this list will be our median. 1, 2, 3, 4, 5, 6, 7. So our median is going to be 17. Q1, on the other hand, will be the 25th percentile. So what we want to do is we want to find 1/4 of the data. It'll be about here. So let's do this. We'll take n, and we want 1/4 of the data. So I want to divide n by 4, which is going to be 3.25. 13 divided by 4 is 3.25. So again, we round up to get 4. So the fourth number in this list is going to be 7. Lastly, we want the third quartile. So what we'll do is we'll take each quarter of the data should be about 3 and 2/5 numbers. So 3/4 of 13. So 3/4 of n will be 9.75, and when we round up, we'll get the 10th number in our list. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So Q3 will be 29. So the first quartile is 7. That will separate about 25% of the data from the rest. The second quartile is 17. That will separate 50% of the data from the rest. And the third quartile is 29, which will separate 75% of the data from the rest. Again, we're just looking at half of the data, 1/4 of the data, and 3/4 of the data to find the quartiles. There are a few common numbers that we can find. So the interquartile range is going to be the distance from the first quartile to the third quartile. So when we come up to the interquartile range is the distance from, let me do this in a different color, it's the distance from the first quartile to the second quartile. So it's the distance from, say, 7 to 29 here. So the interquartile range will be 29 minus 7, which is 22. The semi-interquartile range, the prefix semi normally means half, so it's just half of this range. And what's called the mid-quartile is the halfway point between the third quartile and the first quartile. And one thing that I want to stress, this is not Q2. This is not the median. And we can see this explicitly up here. So where 7 is the first quartile and 29 is the third quartile, the mid-quartile will be exactly halfway between 29 and 7. So if I take 29 plus 7 and I divide by 2, I will get 18, which is not the same as the median. It's not the same as Q2. So this is just something to keep in mind, that exactly between the first quartile and the second quartile will not necessarily be the median. The median could be closer to the third quartile, as it is here. It's 10 away, but it's 12 away from the upper quartile. So even though these are split into chunks of about 25% of the numbers, 25% of the numbers could stretch for a lot longer or shorter. One thing with percentiles is we talked about the interquartile range being the distance from Q3 to Q1. The 1090 percentile range is just the distance from P90, so the 90th percentile to the 10th percentile. So this is just another example of giving it a notion of some distance in there. So the 5-number summary is just a very quick summary of the data. It gives a little bit of notion about where the data, the spread of the data. So we look at both the minimum and the maximum to say, oh, all of our data values are in between here. The second quartile, which is the median, tells you about the middle of the data. So again, half the data will be below the second quartile and half of the data will be above the second quartile. And then the bottom half we split in two, and then the top half we split in two. So out of all the data, we say, oh, we've got the middle of the data, the first quartile, and the second quartile. So this tells you roughly the spread of the data. And we can illustrate this with a box plot, a box and whisker, which is also called a box and whisker plot. And this is, in fact, I have heard this referred to as the box and whisker plot a lot more than just a box plot. And this graph essentially gives you the 5-number summary visually. So you draw a line from the minimum value to the maximum value. So so by example, we draw a line from the minimum value to the maximum value. A box from Q1 to Q3. So maybe here's Q1 and maybe here's Q3. So we draw a box from Q1 to Q3. And then we mark the minimum, maximum, and Q2 as in the median. So the minimum, the maximum, and Q2. So let's go through this and look at the 5-number summary and the box and whisker plot for our prime numbers that we saw before. So if we come back up to the prime numbers, just bear with me for a second. We found Q1, Q2, and Q3, 7, 17, and 29. What are we missing? We're missing the minimum, which is 2, and the maximum, which is 39. So let's fill this in. Again, the minimum was 2, the maximum was 39, the median value was 17, and we had 20 and 29 were the first and third quartiles respectively. So let's draw this as a box and whisker plot. So first of all, I'm going to have a line that'll stretch all the way from 0 up to 40. All of our data values live in this range. So let's cut this in half and in half again so that we have some reference points. So our minimum value is 2. So 2 is about here. Our maximum value is 39, which is pretty close to 40. Our first quartile was at 7, so maybe 7 is about here. The second quartile is at 17, so maybe 17 is about here. And then the third quartile is at 29, so really close to 30. So what we'll do is we'll draw a line from the minimum value to the maximum value, and we have a box that extends from the minimum value, from the first quartile to the third quartile. And this is again my rough drawing here. It's not perfect, but there are some very nice features here. Again, we have the minimum value, the first quartile, the second quartile, the third quartile, and the max. These are called quartiles because they split the data up into quarters. So here's what we expect. 1/4 of the data should belong in this little region, within this whisker. 1/4 of the data should belong to this region of the data, between the first quartile and the second quartile. 1/4 of the data should be between the second quartile and the third quartile, and the last quarter of the data should be between the third quartile and the maximum. So this is a really nice summary because it tells you where the data is. 1/4 of it is in each of these sections. Notice that 1/4 of the data is between 2 and 7. So this is only 5 wide. So 1/4 of all the numbers are going to be in this little range here. But 1/4 of the numbers are also between 17 and 29. So it's more spread out. So things are more compact on this end and more spread out on this end. And you'll find that with prime numbers. They spread out as you get bigger. Skewness, like we saw before, is when the numbers will extend a little bit further, either to the right or to the left. More positively, if they are to the right, as in the right whisker is longer, or negatively, if they're moving more to the left. In this box and whisker plot, this isn't very skewed. Our whiskers aren't super long, but maybe it's skewed a little bit more to the right. The right whisker is a little bit longer than the left whisker. But this isn't very skewed.